Okay, now we move to the next topics. If we use characteristic building and relation with the dynamic performance, dynamic behavior of building. Dynamic behavior means the building that have of a building during the quick motion or quick motion. Quick excitation, and then the building move, right? If the building moving, you have to get the motion. You can study because different structure will have different behavior. Each material will have different. Each substructure will have different very with uh, behavior, dynamic behavior. Okay, and now we have to start. Yeah, this is the formation of buildings and the dynamic behavior. Its dynamic behaviors. So the building that is satisfied, yeah, that is satisfied in the performance of characteristic will perform the satisfied to with there is a check the buildings. So formation, if characteristic of the building, will directly affect the vulnerability of the building, and parallel to the risk of the damage of the building because of earthquake shaking. So you as a designer, right, you have to able to clarify, to explain for the owner as big as your team, big team as your team, because you are maybe the member of the team, the head of the team, maybe from the architects or maybe from the environmentalists, and you are the team, or maybe you self as a leaders of the team. Okay, and you have to explain because it's not. Yeah, people and owner like to have a building that is very complex, but the money is limited. This is the problem. So you have to explain. If you have much money, okay, all of the building that you like and you would like to design of you, but maybe it will have a costly. It will have a building that is very costly and the construction. The important formation or characteristics of the building here to the by Dodrick in the 1977 is that the configuration and the type of upper structures, and then second is the types of material for the buildings. For example, uh, using the concrete, as was concrete, or using the brick, or using the steel materials will have a different. So, and then number 3 is the effect of non-structural elements in non-structural. Then plus the formation and the types of substructure, including the foundation and the pure foundation and piles, and maybe using piles, maybe using shallow foundation or deep foundation. You have the subject of deep foundation, right? You have subject of foundation, be shallow and be deep, foundation. Okay, now if we talk about the configuration of the type of structural, upper structure. So which one that the dynamic behavior will satisfy? Mean that would make that the building much more stronger, mean more resist to earthquake. That is if you make the building is similar and then symmetry, it's not too long and not too slim, yeah, and then having the plastic plastic hinge in the beam, yeah, other than in the column. Mean that there's strong column, big beam. The concept of strong column, big beam. Five, have the strength, stiffness, strength, stiffness, yeah, stiffness that far from the period, yeah, of the frequency of the soil below it. You need it. Because if the same mean there is a resonance. Mean resonance, you will have the maximum loads because of earthquake taking. And how about the simplicity and symmetry? Simplicity and symmetry, if you have to have the very simple building, simplicity, simple building, yeah, you will have it easier to predict the behavior of the building. So you will much safe to design the detail in detail. In describing or if we study or capture the dynamic behavior of the building, we could go in the global of the overall building, or maybe only in detail. Yeah, maybe material, elemental, maybe segmental. For example, the column, beam column, and maybe in the one story, or maybe as a structure, one structure of the building. But global more than structure, including non-structural, or number one. Okay, for the symmetry of what they will have the not having effect the torsion. Torsion. If you have eccentricity, means not symmetry, you have eccentricity. Eccentricity having torsion that make larger and larger force that should be resisted by the buildings. So what should about the plan of the building here? So do and done, yeah, and the reason. The symmetry of course is one. So like we should having temples, yeah, candi-candi. So it is better to what if or a separate complex, yes, very difficult, complex, very much difficult. So analysis very, and maybe we will have a very costly, yeah, expensive building. How about if very long? It's not good because there is the different behavior in the ends here to ends. So it's better to say cut, yeah, to make it shorter by using cap, yeah, to cap, yeah. Okay. Then, for example, this is using slim here, and slimming like this one is better using more fat like this one. So, because it will be different to the way is to separate the building, yeah. Like in the FTSP building for our FTSP building, yeah, in our building in campus, FTSP, yeah, our faculty. Yeah. Actually, they have 5 buildings. Yeah, it looks like there's only one, but there are 5 structural systems. Yeah, so they will move each other differently during earthquake. So that's why there is some damage in the ceiling. Yeah, not the ceiling, but in the parapet. Yeah, parapet at the top of the close to the roof. Yeah, because having bumping each other, bumping each other. And then about here is the side structure, the detailing is not easy, right? But even if you have different, it is not symmetrical. You have trouble, more trouble. But okay, you have to to clarify to the owner and team that if you would like to have the different, it's like this one, it's okay, but the consequence is you have to have more time and then more money to construct. Okay, so there is to make it easier, there is a cap, yeah. This thing is not having one. And then slim building, yeah, and softer building here is better. But slim is flexible and not can be used for the sheer building. So, yeah, tone and here effect of setback, like architecture and the owner like this one. Yeah, but you have to uh, think, consider that this is much more need more serious in your design. You have a similar tension level of attention between the left and right, so you will have problem because maybe the right one becomes more vulnerable or less resistant. Distribution here, distribution of the strength and stiffness, better to have the building that like this one. This is a continuous regular, but this is made much more serious. This, for example, also you need attention because maybe the damage in the place. Maybe the damage in the plant or the joint. If the collapse, uh, first floor, of course, all of this building here will collapse. This is also having need more stability, yeah, foundation, etc. So if you, for example, you if you could decide delete one, okay. If not, you have to spend more time and energy to design to make it still resist the earthquake. Okay, and then in the earthquake prone, it is better using column and beam system. Yeah. But not only column and slab, you have rubber. The distribution is not easy to distribute more. Yeah. Beam is better to distribute the loads, the floor loads. How about the vertical and horizontal member? Yeah. Over here, here. This is the actually the beam, the horizontal beam, and this column is vertical. Yeah, but it's not proportional. You have to have the hinge. Yeah, plastic hinge is better in the beam. Yeah, beam here. So energy distribution better in the beam because the beam can parallel. Yeah, it collapse, and then still you still have a more other beam there. But if column here, for example, column in the bottom collapse, so upper column can could not resist, yeah, resist and all will collapse. So that's why the hinge, yeah, the hinge, the plastic you call it, yeah, you have to put in the beams. And then you have also to strong column, big beam, yeah. So that's why just you have to have the strong column beam, strong column, yeah. Hmm. you. Because there is a between the stiff structures and flexible structures, yeah, different performance. There is the table to compare it. Yeah. So flexible, what is flexible? Mean there is a plus and minus, yeah, advantage and disadvantage. All of them, the human being created, yeah. Human being creates all have plus and minus, advantage and disadvantage. Advantage keuntungan is that if you have the place that is the short period of the building, short period, so easy, inflexible, because will not make is far from the resonance. So you will have smaller force to record. Ductility could be reached more easily. And analysis, structural analysis is easier. How about the disadvantage? If you have the site that have long periods like alluvial, will have trouble because it needs also resonance. It will have get the big force for your buildings that you are designing. And most of the material using reinforced concrete, but it is not easy to design a flexible for earthquake for the reinforced concrete. For steel structures okay, but for concrete is not so flexible as steel. Even you have the reinforced steel concrete. If in this flexibility here, if you have non-structural like walls, you will have also big effect. Your building will have big effect. Then non-structural it's not easy to detail. Also big displacement. It's not easy to find to make a for a glass, yeah, window that is from the glass. The window or door glass is not easy to move, yeah, left and right. So you have to separate it by using, for example, rubber. How about the stiff? Yeah, of course, vice versa. Before advantage become disadvantage become advantage for this kind. If we compare to flexible, and this is the good thing is that the shear wall, yeah, you can make it shear wall. If there is a frames, then put shear wall to make it more stiff, stiffer. Non-structural, of course, is here to detail because it will small displacement during the big earthquake. But ductility is not easy to find out because it's too strong. Easy for ductility for if the structure is flexible. Okay, and analysis is not easy too because your wall is not easy. There are frame to analyze using the structural analysis by using front frame that zero walls. But this is good. Authoritative is smaller, detail is here. To develop the uniform plasticity of the structure and less P delta effects. P delta effect is, for example, is you have a structure, yeah, and there is P here, yeah. If this stiff is okay like this, if not, if flexible like that, like this one, flexible, maybe it's not good. Okay, I tried this, yeah. This is P become here. So there is a delta here. So now we have moment, what copy? This is P, yeah, P here, time delta. This means P delta effect. So there is a extra moment. This means P delta effect. Make the force larger and make the resistance need to be increasing. Mean energy, time, and money expensive. How about the material of the structures? Yes, it was different. Yeah, material of the structures different. Ductility, high ductility is okay. Yeah, the ratio of the strength and the weight is high. Okay, good. Homogeneous. And then form to form for the full, like if we make here in situ concrete, not precast concrete, precast concrete. There is a less full relationship. There's a less decrease the relationship for the full strength. Okay, there is here. If you like to have a high, very high buildings, and using the high building, mean you have to use better using steel structure. And if it's not so tall, you have to use a concrete structure, reinforced concrete. Yeah. If you use only small, like story, 1 story, for example, even you can use the wood structures, yeah, even using the reinforced uh, reinforced masonry. It's okay, yeah. In the middle here, the middle story for the high story building. This one, yeah, story building. One, short story is this one, yeah, short buildings. How about non-structure? Non-structure could make different behavior of the people, but especially for the flexible structures. Because I put uh, walls, for example, masonry wall will have effect. So the period of the building become smaller. Because the building become more stiff, yeah, stiffer. Yeah. The stiffness is increasing. But this only for small displacement. A big displacement, of course, wall is not enough. Wall is not enough strength. That, yeah, to prevent the large displacement. About the substructure, yeah, substructure consider including the foundation, yeah, and the connection, etc. Yeah, maybe the bend, yeah, foundation bend. So we call it slope, yeah, including. So if the vertical symmetry, so foundation is economical, more economical. Yeah. So the returning, yeah, turning moment, yeah. So returning moment the moment will be smaller, and it could the foundation it can efficient. And if the structure is not so long, and then the different style of settlement will be limited. Then it also make more economic for the house, and even this one will go to uh, will reach the building that we need that is more resistant to differential settlement is there is a settlement after you make a building. The building will go down because the compaction of the soil. But if this is different, yeah, it will make trouble. Maybe there is damage on the building. But if going together, but limited, of course, and then we'll make okay, but no problem. But the philosophy of the earthquake before we have already discussed for the lecture of 11, yeah. This is lecture 12. I think it's all. If you have any question, you just ask the question. If not, later you will. I'll give you the question by using the problems. Because if you don't have the problem, you don't know anything to ask. And then if I ask, and then you know that you don't know, yeah, or maybe you know that you know, yeah.